Alright, in this video what we're going to do is extend our practice of Lewis formulas to deal with molecules that have charges on them. Alright, and the first example that we're going to work together is going to be ammonium. Ammonium, which is a derivative of ammonia. Alright, except that ammonium has an additional hydrogen attached to the nitrogen, so there's a positive charge on the molecule. So we would call this actually a polycation. It's a polycation. All right. So this is a molecular ion. All right, and it is a polycation. A polycation. I'm going to put that over here so it's out of the way. Polycation. All right, now, so we need to add a step to our list of steps. So we're going to make this step number 6. All right, and in step number 6 deals directly with charged molecules. All right, and there's two possibilities for a charged molecule. You can either have a positively charged one or a negatively charged one, and we're going to do a number of different examples where we flip back and forth between those two possibilities. So in the case of the positively charged molecule, what's going to happen is you're going to subtract the charge from the total valence count. All right, and then the other option is if it's negatively charged, if it's a negatively charged particle. So in this case you will add the magnitude of the charge, all right, to total valence count. All right, now, like we've done in the previous videos, you handle this exactly the same. You follow the steps. You follow the steps. All right, so first thing we're going to do with NH4 is we're going to do our total valence count. So nitrogen, it comes out of group 5A, so that's going to be 5. Hydrogen's out of group 1A, so that's 1 valence electron, but there are 4 atoms. You can see right now if we added this together we would get an odd number. That's not going to be good, and since the charge is a +1, we go ahead and we subtract that charge from the total count, and lo and behold we get 8. So this is our magic number. So okay, next step, we draw the skeletal structure. All right, and literally I'm just going to put the hydrogens around the N, following the rules or the steps. Next we connect. Connect everybody up. We do a quick count. 2, 4, 6, 8, and we see that in this case, all right, we're done because we have used the total valence. So we've met with the criteria that we've used the total number of electrons that we were given to start with. All right, the only thing we need to be sure of is that we met the octet rule and that we have 8 electrons around the nitrogen, 2, 4, 6, 8, which we do. And remember with hydrogen, hydrogen can never be next to more than 2 electrons. So as we look at the hydrogens here, each of those is fine because each hydrogen is only bonded to 2 other electrons. All right, now what we'll do next is flip to an example of a molecule that has a negative charge. So we'll look at cyanide, Cn-, and again we're going to follow our steps. Paying attention to step number 6 here, that since it's a negative charge, we're going to be adding that charge to our total valence count. So let's see. For carbon, we're in group 4, so that's going to be 4 valence for the carbon. Nitrogen is in group 5, and we add the charge, which happens to be -1, so it's +1. And we have 5 plus 4 is 9 plus 1. We get a total of 10 electrons for our valence count. This is our magic number. So now we continue to follow the steps. So we write carbon and we write nitrogen next to one another. And I think in order to really illustrate how the steps work for you, we'll just blatantly follow them. So I'm going to connect, and then I'm going to put in my unshared pairs of electrons so that each one has no more than 8 around it. And now I count 2, 4, 6, 8, 10, 12, 14. So this structure is wrong. Now remember from the previous video, by adding multiple bonds, we can reduce the total electron count. And in this case, I'm going to tip the viewer off to something. We've got 10 electrons here. Remember that N2, which has a triple bond, also had 10 electrons. So I'm going to go ahead and take a risk here, and we're going to put in 3 bonds between the C and the N. And do a quick electron count. That's a total of 6 electrons. All right. So that means that we need to use a total of 4. And so let's go ahead and put in our unshared pairs of electrons. And remember, as we do that, we cannot exceed 8 electrons around each of the atoms that we're adding the unshared pairs to. So that means that for the nitrogen that we're done here, it's 2, 4, 6, 8 on that one. And we'll put our other unshared pair here. All right, and count for the carbon is 2, 4, 6, 8 for that one. All right, so we see that in the case of this structure, that we have met our magic number. We have 2, 4, 6, 8, 10 total of electrons, and that matches up with this. So this is the best structure. All right, now let's go ahead and try a more complex molecule for the next example. So let's take a look at this thing. It's a CH3 group bonded to NH3, and there's a positive charge on the molecule. How are we going to deal with this? All right, so what we're going to do again is we follow the rules. So we want to count our total electrons. We have a carbon in here, and carbon is in group 4, so we're going to have 4 valence electrons. There's a total of 6 hydrogens. Each hydrogen is worth 1 valence. There's a total of 6. There's 1 nitrogen, and nitrogen is in group 5, so we add that. And then we have a positive charge on the molecule, so we're going to subtract 1 from the total. And what we get is 14 electrons. So this is going to be our magic number. Magic number. All right, skeletal structure. The carbon and the nitrogen are going to be our central atoms. So I'm going to go ahead and write them in. The carbon and nitrogen side by side. And then we're going to place the hydrogens around each of the respective central atoms. So we're going to have a hydrogen here, and a hydrogen here. I'm going to have a hydrogen here, and a hydrogen here. Whoops, getting ahead of myself. Okay, now what we're going to do next is follow the steps. So I'm going to go in and I'm going to connect all my outer atoms to my central atom. See if I can get that a little bit better so that they're not. So you can. Okay, good. Now, before I move on to the next step, again, we need to do that quick electron count. So let's get that done. It's going to be 2, 4, 6, 8, 10, 12, 14 electrons. So I can see right now that I've actually met my magic number. All right, I've used the total valence. The question is whether or not I've met the octet rule. So we need to do that next. Never skip that step. So we see that we've got 2, 4, 6, 8 electrons around this nitrogen, and then I've got 2, 4, 6, 8 electrons around this carbon. So in fact, we have passed step number 5 here. All right, we've passed step number 5, and so this is the correct structure for this molecule. Now, I realize in pushing through this that I have neglected to do a simple thing regarding the charge. So coming back up to my ammonium, I'm going to put a bracket on this and put a charge here, just to remind you that there is a charge on this molecule. All right, and we have the same situation here with the cyanide. All right, it has a charge of -1 on it. And then similarly, this particle, okay, has a charge of +1 on it. All right, now I think we have time for one more example. And on that one, we'll do BH4. So boron tetrahydride. It has a negative charge on it. All right, now moving forward, the boron is in group 3, so it's 3 valence electrons. We have 4 hydrogens, each worth 1, and it's a negative charge, so we're going to add an electron. So the total electron count here is going to be 8. Now I draw my skeleton structure. We're just going to go ahead and put the hydrogens all the way around. Following the steps, I go ahead and I connect. I do my quick electron count, 2, 4, 6, 8. Magic number is hit. So we've used the correct number. The last thing we need to do is just make sure that we met the octet rule. So we have 2, 4, 6, 8 electrons around the boron. So this passes both of the tests. I'm going to add a bracket and put a negative charge here. All right, and that closes this video, and we'll move on to some other examples.